Now, today we shall discuss 8 different most important questions which have come in our different competitive exams like JEE Main, like NEET in previous different years. The first question is, this is the compound benzene ring attached with COCH2Br. It is treated with sodium borohydride first and then methanol at 25 degrees centigrade. The product is P. Now, we have to find out what is P, the structure of P. First, we have to draw the compound, this benzene ring COCH2Br when treated with NaBH4. In presence of NaBH4, it first forms benzene ring and CO group get reduced by CHOH by NH4 to form the secondary alcohol and CH2Br. This is the compound. But this, when treated in presence of methyl alcohol at 25 degrees centigrade, a neighboring group participation takes place. NGP, neighboring group participation, where the lone pair of the oxygen attacks this positive charge, del positive charge CH2 group to liberate this del negative charge Br minus, and hence the product is CH. This compound is CH2, but here the oxygen forms an epoxide, liberates Br minus. This is the mechanism through which it produces an epoxide, and hence this will be the product. Number 2, here there are actually 4 different compounds. We have to form an order, increasing order of their basicity. We have to arrange these compounds in increasing order of their basicity. Now, basicity, that means how readily, according to the Lewis theory, how readily it can donate its lone pair to the other substance. So, on the basis of this, we can compare the basicity of these 4 compounds. We know that the B here, A, it has a lone pair over it and it has a tendency to donate this lone pair. But the lone pair over the nitrogen, here this nitrogen, sorry, this will be the NH, this nitrogen will be sp2 hybridized, and that's why higher this character, less has the tendency to donate its lone pair to the other substance. So B, where the double bond N is attached with the double bonded carbon atom, is the least basic substance. So B has the least basic strength. Now, if we compare these, first double bond, the lone pair is attached with the single bonded carbon. Here the lone pair is attached also with the single bonded carbon, but this lone pair, when donated to this substance, it readily donates this particular part. But such type of donation cannot occur in case of A. So, in between A and C, though both compound has double bond, but here through resonance, the donation, that means it occupies the negative charge, and readily donates this negative charge to the other substance to accept one proton or like this. And that's why A is less basic than that of the C. Now if we compare D and C, here it donates through the resonance, but here it donates through the plus I effect, because ethyl group has plus I effect, it donates the electron density, as well as methyl group has plus I effect, it donates the electron density towards the nitrogen. So plus I effect, we know that increases the basic strength, but here due to the presence of bulky sized groups of the ethyl as well as methyl, bulky sized, so the donation is somewhat less as compared to this, where such type of free donation occurs through the resonance. So the order will be BADC. C has the highest basic strength. The order is this, BADC. Question number 3. This is the compound. Here, this is also an ether, this is also an ether. But the oxygen is attached with the alkyl group, attached with the benzene ring. But here the oxygen directly attached with the benzene ring. But this compound, when treated with HI in excess, the product is X, we have to identify X. Now, if it is treated with HI, then the first lone pair is protonated and this lone pair is also protonated to form this compound at first. OH plus this. and this is also OH plus. Now iodine minus, if or whenever iodine minus attacks this center, because iodine doesn't attack to the benzene ring. If iodine attacks this center, the bi-bond dissociates to single bond dissociates to form such type of carbocation here. Here it forms a carbocation. And also another I minus, when attacks to this center, it forms alcohol, phenolic part. Now the second I minus, but this I minus cannot attack to this center because the substitution reaction doesn't occur at the benzene ring, because this carbon is sp2 hybridized. So substitution cannot occur. But here, though it is sp2 hybridized, but it readily gets substituted by this I minus because it is not attached directly with the benzene ring. So that's why the final product will be. So this reaction doesn't occur, but this reaction occurs. The final product will be I, but here OH. This is the X. Final complete. Question number 4. This is the compound. Here bromine is above the plane with respect to this cyclohexane system, and it is treated with, this compound is treated with sodium methoxide in presence of methanol. What will be the major product? So two types of products are obtained here. If by SN2 reaction, that means substitution reaction occurs, the nucleophile here OMe minus, that means methoxide anion, approaches from the back side and liberates this group Br minus. So the product will be like this. Product will be, the OMe comes from the back side, so it will be below the plane. This will be the final product. And if the reaction goes through elimination process by E2 mechanism, then this hydrogen atom will be eliminated. Attached to this center, it forms a double bond here and liberates this and forms an alkene like this, cyclohexene. It forms this. But among these two products, what will be the major product? E2. That means elimination product will be the major product, because the final product contains an sp2 hybridized carbon atom, the bond angle of which is 120 degrees. But here the final product is sp3 hybridized carbon atom, bond angle is 109 degree 28 minutes. More sterically hindered, and that's why it is somewhat less stable than that of this. So elimination product will be the major product. 5 is this compound. That means CH3 whole to CH, CHOH, CH3 is treated with H plus. On heating produces two compounds. One is the major A and the other is the minor B. Now B, that means which is the minor product, when treated with HBr, again give two different products, C and D, of which C is the major and D is the minor. We have to identify A, B, C and D. Now the first compound, when treated with H plus, the first structure will be CH3, CH3H, single bond CH, OH2 plus, single bond CH3, and by removal of the OH2 plus, that means H2O, it forms CH3, C, CH3H, single bond CH, this will be plus, and CH3. This is the final product. And if it forms the major and minor, the major product will be, this will be the alkene. The major product will be CH3, C, CH3, double bond C, H, single bond CH3. That means 2-methyl butene. This is the major product. That means this is A. But if the double bond, that means this is the Z product. But if the double bond forms from this side, that will be the minor product. So it will be Hoffman product. CH3, C, CH3, H, single bond C, CH, double bond CH2. This will be the Hoffman product, CH2. This is the minor product. That means this is the B. Now B when treated with HBr. First it is treated with H plus. So it generates a carbocation at this carbon CH3 whole 2 CH single bond CH plus single bond CH3. This is the first part, and this when treated with Br minus, first it forms, actually it forms first this carbocation, and this carbocation first when treated with Br minus, it will be CH3 whole 2 CH single bond CH Br single bond CH3. This is the minor product, that means this is D. This is the minor product. But here a rearrangement occurs through the hydride shift. If this hydride shift takes place, that means this is the 2-degree carbocation. If this hydride shift takes place, then the final product will be CH3 whole 2 C plus. This is a 3-degree carbocation, CH2 CH3. And now this 3-degree carbocation when treated with Br minus, the final product will be CH3 whole 2 CBr single bond CH2 CH3. This is the D, sorry, this is C. C is the major product. So from the minor compound, that means Hofmann product, we shall obtain two different compounds through the formation of a 2-degree carbocation. If Br minus attached to that 2-degree carbocation, then minor product will be D. If a rearrangement occurs, then a more stable 3-degree carbocation occurs, and Br minus if attached to this 3-degree carbocation, then a major product will be C. This is the A, B and C, D. Question number 6. First, 1 mole of acetone MECOMe plus 2 moles of methyl magnesium iodide. That means it is a Grignard reagent. 1 mole of MECOMe methyl acetate, 3 moles of methyl magnesium iodide. 1 mole of methyl MECHO, that means acetaldehyde, 3 moles of MEMGI, methyl magnesium iodide, and 1 mole of dry ice plus 1 mole of Me3CMGI, which can form Me3CCO2H, tertiary butyl methanoic acid. So this particular 4 reactions, we have to observe all these 4 reactions. Number 1, 1 mole of MECOMe. This compound, when treated with a Grignard reagent like MEMGI, and we know that in between these two parts, this will be negatively charged and MEMGI is positively charged. So methyl attacks this nucleophilic center, dissociates the double bond. In presence of H3O plus, it forms OH, methyl, methyl. And if 2 moles of MEMGI, that means second mole of MEMGI reacts, it forms methane as a gaseous product. Number 2, 1 mole of MECOMe, MECOMe. This when treated with MEMGI, that means the negative charge attack this center and dissociate this linkage, it first forms a ketone, and this when treated with again 2 steps through the reaction, it forms methyl hydrogen, that is methane. In case of 3, acetaldehyde, this when treated with MEMGI, methyl magnesium iodide, it first reacts with this, dissociate this linkage. In presence of water, it first forms OH, methyl hydrogen. But this compound when treated with again methyl magnesium iodide, it again forms methane. So the 4th compound, in the 4th reaction, we have seen that Me3C MgI, that means this will be the negative charge, this is the positive charge, reacts with the CO2, dry ice. So an electrophilic center, a nucleophilic center occurs in presence of CO2, dissociate this linkage to form first Me3C single bond C double bond O OMGI, which when treated with H3O plus produces the desired compound. So 4 will be the answer. Me3CMGI treated with dry ice to form Me3CCO2H. 2-methyl-buta-1,3-diene when treated with HBr1 equivalent produces X. X is the major product. So you have to identify X first. CH2 double bond C, CH3 single bond CH double bond CH2. That means where the positive charge occurs more readily. If this forms, suppose we have to identify this center. positive charge. So CH3 group has a plus I effect. This decreases the positive charge, decreases the positive charge over the carbon atom. But here no such type of attachment occurs. But on the third carbon this attachment occurs, and we know that I effect decreases with the increase of the carbon chain. So this actually is the center where the addition of HBr takes place, not here. So first we have to identify where the addition takes place, because here two spaces are observed where double bonds occur. So this is the place where HBr attached, should be attached, because the addition reaction goes through this double bond. So first CH2, that means if Br minus attack this center, double bond dissociates to form this CH2 double bond C, CH3 single bond CH2 single bond CH2. So this will be the CH2 Br. This is the 1,2 addition product. But another product will be obtained where 1,4 addition may be obtained. This here CH2 hydrogen single bond C, CH3 double bond CH single bond CH2 Br. This is 1,4 addition. This is the major product. So actually X will be this. In our previous video we have observed that such type of a compound, benzene ring attached with the NH2 group, and at the para position there is a CH3 group known as the para-toluidine NH2CH3. But if or whenever an electrophile attached to this benzene ring, where it comes, here the two different groups are attached. One has minus I but plus R effect, and other has only plus R effect but it has also hyperconjugational effect. But here orientation of an electrophile or a nucleophile, whatever may be, orientation depends on the R effect of the group already present. That means R effect of the NH2 group, and it is ortho-para directing because it has plus R effect, ortho-para directing towards an electrophile. So either ortho or para position will be activated, and here if we have seen that CH3 group is attached at the para position, so ortho position is opened and hence electrophile comes at the ortho position. This is the first case. And in the second case, if we see that the conjugate base, so if we compare the conjugate bases of different structures, the conjugate base, which one is more stable? We know that higher the stability of the conjugate base, stronger will be the acid. So the acid strength depends on the conjugate base. Now conjugate base, stability of the conjugate base depends on these two factors actually, minus R effect and minus I effects. So with the increase of these two effects, the acid strength increases, stability of the conjugate base increases. And among these two, we know that minus R is more pronounced because through R effect, it either withdraws or donates, whatever may be, either plus R or minus R, whatever may be, a pi bond occurs, and through pi bond a maximum donation occurs to the benzene ring or withdrawal occurs through the benzene ring. But minus I, only a partial donation through the sigma bond occurs, not complete transfer of electron occurs. That's why this is more pronounced. So if we compare the different conjugate bases, the stability of the different conjugate bases, so we have to consider first these two effects. Where minus R effect operates, that will be more pronounced, so that will be stronger acid. That means the conjugate base is more stable as compared to the minus I effects. And we know that plus I decreases the stability, plus R also decreases the stability among these two. That means minus R greater than minus I. But so the conjugate base is more stable in case of minus R. But if plus I and plus R both are present, then plus I stabilizes more as compared to plus R. So plus I is more stable than that of plus R, because plus R donates the electron density to the benzene ring through the substance, and hence it decreases the stability of the conjugate base. So the order is this, minus r greater than minus I, but plus I greater than plus r if we compare the stability of the conjugate basis. So all these are these explanations will, I hope, will help you to compare, to construct the concept in your mind. Thank you. If you have any problem, then send me in comment box.